When the cosmic microwave background was discovered in 1964, this very smooth, even radio radiation coming from all directions at once, the smoothness of the microwave background was considered a proof of the existence of the Big Bang. Only a universal explosion, they argued, could create this smooth, even background.
Now, this is not necessarily so. Actually, the 3-degree radiation, to me, has not a cosmological value. It is observed in any cosmology. In any cosmology, you can predict the 3-degree radiation. So it's a proof of no cosmology at all if it can be predicted by all of them.
There's no explanation at all of the microwave background in the Big Bang theory. All you can say for the theory is that it permits you to put it in if you want to put it in. So you look and it's there, so you put it in. It isn't an explanation.
First of all, the temperature of the microwave background, basically the amount of energy, was not what the Big Bang supporters had predicted. They had predicted a much higher temperature.
So it was 50 degrees Kelvin that was being compared against the 2 to 5 degrees Kelvin from the steady state universe. Now, this may not sound like much, but in energy density, where we measure the absolute differences, the differences is 4 orders of magnitude, 10 times 10 times 10 times 10 difference. So there is an enormous difference between 50 degrees Kelvin, a rather poor indicator of what is happening in the universe, and 3 degrees Kelvin.
When you read the textbooks, they don't tell the whole story. They don't present these figures, 5 greater than 5, 7, 50, and then that they did find 3. So that's very strange how the textbooks, they hide a part of history.
And the temperature of the Big Bang proponents was rapidly readjusted from 50 degrees to 3 degrees.
But their theory could be adjusted so that the temperature becomes a free variable that it could be just taken as what was observed.
We have an observable universe which is made of stars, galaxies that are not very distant, and that's all, because the 3-degree radiation, I would even think that it might be local. Still not. And going beyond that is, I think, a wild extrapolation, whatever it is. And physics that we could imagine to be existing there is based on nothing, because we have no test for it.
Although Big Bang advocates claim the discovery of the cosmic microwave background radiation as conclusive proof of their theory, history actually shows that there is a long line of well-hidden predictions previous to those made by Big Bang theorists. Not only were these predictions prior to those of Gamow and associates, but more importantly, they were made without any need for an expanding universe, and with far greater precision. This shows us that observations such as the background temperature of space have no preference for one or another theory, and therefore may not be used as definitive proof of any particular model. The fact that a theory is able to describe an observation does not mean that the observation proves the theory.
This is Bob Wilson at Bell Laboratories. The noise you're listening to is noise from a radio astronomy receiver on the 20-foot horn reflector antenna. This is the original instrument with which Arno Penzias and I discovered the cosmic microwave background radiation in 1965. This radiation comes from all directions and has a thermal spectrum. It sounds, therefore, very much like the noise you would hear on an FM set or a TV set which is tuned to an unused channel. Unfortunately, only about 10% of the noise you hear is coming from the cosmic microwave background radiation. The instrument is contributing about 22 degrees or noise. The Earth's atmosphere is contributing another 4 degrees. Our Milky Way galaxy is contributing 1, and finally the cosmic microwave background radiation, another 3 degrees.
When you say that the microwave background is a perfect black body radiation, that means it is completely thermalized. The theory of black body radiation tells you that that is the ultimate state of radiation when all information of sources from where radiation came has disappeared. Because thermalization means that it's completely smoothed out, wiped out its sources.
One of the main things that people point to as confirmation that the Big Bang is a valid theory is its predictions of abundance of the light elements. That this confirms that the theory is a good theory. But in fact, it doesn't. In fact, observations clearly contradict this prediction of the Big Bang. Big Bang predicts the abundance of 3 elements: helium, lithium, and the isotope deuterium, which is the heavy isotope of ordinary hydrogen.
Now, one of the conclusions from this particular hypothesis that you can make deuterium in the Big Bang was that the density of matter in the universe should not exceed a certain value. Now, over the years, in the 1960s, this seemed to be holding out. 1970s, it seemed to be holding out. But by 1980s, it had become clear that the universe has considerable amount of dark matter, which is not included in these calculations. Now, if you include all this dark matter, you exceed the limit that deuterium abundance has put. That means if you assume that all the dark matter is present, then you could not have made deuterium in the amount that is observed in the universe. So this was a way of saying that the Big Bang prediction was wrong.
To determine the density of the universe and see whether this is consistent. If the theory is right, the density of the universe determined from deuterium abundance, the one determined from lithium abundance, and the one determined from helium should all be the same number. There can only be one density of the universe. While actually that's not true. Again, these are gross contradictions, and yet again, it doesn't cause the abandonment of the theory. Big Bang theorists simply say, well, there must be something that we don't understand about the evolution of lithium, about the evolution of deuterium, and even though these predictions have steadily diverged over the course of time.
But what did the Big Bang proponents do? They wanted a way out, so they said that this extra matter, which is proving to be awkward to fit into the framework, has to be a strange kind of matter, which is often called non-baryonic matter. Non-baryonic matter is basically matter which is not made of protons, neutrons, and the kind of elements that we are made of here on the Earth, or which we see in the stars or in the interstellar medium.
Dark matter. What was dark matter? Dark matter was some matter that we don't understand. We don't know what it's about. We haven't observed it. But it isn't ordinary matter, so it doesn't enter into our equations about the light elements, and we can't see it as stars. But dark matter is 90 or 99% of the mass of the universe. This is what we call in science a fudge factor. When your equations don't work out, you just write in this little plus something. Well, in this case, this was a humongous fudge factor because it was 90 or 99% of the universe.
And you have to not only postulate that this matter has to exist, but it has to exist in quantities much greater than the amount you see of ordinary matter.
And I should emphasize that people have looked for dark matter. People have looked for dark matter since it was proposed 20 years ago. Axions, WIMPs, little particles that are supposed to be floating around in space that we should, in theory, be able to observe as they pass through the Earth. Dozens of experiments have looked for these particles. Not one has been found. Again, this should be a contradiction. The way science works, you make a prediction, observation contradicts it, the theory should be rejected. But that hasn't happened. And the epicycles don't end. There's a problem with dark matter, even theoretically. Even though we can't observe it, there's still a problem with it, which is dark matter slows down the expansion of the universe. So the length of time that the universe has existed, the length of time since the Big Bang, should be shorter than what's indicated just by linear expansion. The problem is it's too short.